Alright, so these don't have the same impact in this online situation, but these are a big part of we're a big part of our tests in person. And if we come back in the second semester, you'll see a lot of these type of things on tests. It's very important that you're trying to get the most out of the notes and push yourselves as much as you can in this situation. And come to office hours when you need help. Okay, so this is a warm-up. Hopefully you've done this whole thing already. If not, pause right now. We've done a couple of these by now. Pause it, do it yourself, then check. Okay, so this first one is in point-slope form. So that means that there's a point and a slope. So the point is the opposite of x. It's going to be -6, and the opposite of y, that's going to be +7. And the slope is going to be right there, being multiplied by x. So -6, 7 is right here, and the slope is down 7 to the right 3. So down 7 to the right 3. Okay, and we can do that again. Okay, so when I try and graph a line, I try to use these 2 points that are farthest away from each other. And just because you have a bubbly point there, you still want to aim for the middle where the lattice point is. Try to keep this line in the right place. These lines, it's very important that they match up properly to find the points of intersection and so on. So our next line here is what? What do we call that kind of line? Horizontal, you're right, good job. So that's going to be horizontal, horizontal. And y equals 7, so that's going to be up here. And there we go on that one. I'm trying to color code these a little bit. So that last one, that's in standard form. We could write these down. That's in point slope. Pretty sophisticated name, point slope, because it's a point and a slope. This one is in standard form, standard, and that's good for finding the x and the y intercepts. So if we plug in 0 for x, some people call it the cover-up method, because if x is 0, -7 times 0 would just be 0. So basically you can just cover it up. And if we divide both sides by 3, we find out that y equals 7. And then if we do it the other way around and let y be 0 and divide by -7, we get -3. So 0, 7 is up here, and -3, 0 is right there. Now, normally I would probably put another point on there, but I can see my other 2 lines, and so I'm just going to finish that up. I think I mentioned that on other tests, sometimes we graph more stuff on the graph, and so some students erase these lines. Don't erase them all the way to the triangle, because it does say graph these lines, so there should be arrowheads on the way. So if you want to erase part of it, you can, but make sure you have an arrowhead on those lines. Okay. Now, there's a couple different things going on there, so we want to be careful that because it looks like there's a triangle over here too, but that's the y-axis. That wasn't one of our lines. So I want to focus on this triangle over here. Okay. So that's the triangle we're looking at. Now, for the area, we probably want to make sure we put units squared on there, and for the perimeter, maybe we want to make sure that we write units. Classify the triangle, we probably could do that right now, I would think. So hopefully you notice the size of all 3 of those angles. That's going to be an acute triangle. And I would hope you could kind of tell, if you think about it, because this is 3 and that's 7, that's going to be the same on both those. So these 2 are equal. So that's isosceles when there's 2 equal sides. Okay, so if we go to find the area is one of a triangle is 1/2 the base times the height. So the base is 6 and the height is 7. So we're going to have 1/2 of 6 times 7. That's going to be 21 for the area. Units squared. Don't forget the units. Okay. Now the perimeter, that's going to be 1, 2, 3, 4, 5, 6. So we have one side is 6. Now, if we think about this side over here, we could use the Pythagorean theorem. This is 3 and this is 7. So that's going to be 3 squared plus 7 squared. So that's going to be 9 plus 49, which is 58. And that doesn't have a perfect square factor. It's 2 times 29, but that's not helpful. So this is going to be root 58, but so is this. So we're going to have plus 2 root 58 for that. Okay, and that wraps up that warm-up. And we'll start today's lesson. So, parallelograms. We're talking about parallelograms today, properties of parallelograms. That's our objective. Learn as much as we can about parallelograms today. So, a parallelogram is a quadrilateral. Quad is 4, lateral is sides. So, y'all know what a quad is. You've heard of that before. And lateral is side. So, 4 sides. Both pairs of opposite sides are parallel. So that's what makes them a parallelogram. These are parallel, those are parallel. If a quadrilateral is a parallelogram, so I didn't want to write that, we didn't want to type that 4 times, so we just typed it once, and then these are the cases. So if it's a parallelogram, then its opposite sides are congruent. So we can do this and this. So if we have a parallelogram, then we know that that's true. If we have a parallelogram, then the opposite angles must be congruent. Okay, so those two have to be congruent, and those two have to be congruent. Okay, the consecutive angles have to be supplementary. So if you think about it, parallelogram, opposite sides are parallel. So those are parallel, and that's a transversal. That's a transversal as well. So these two angles are same side interior. So, or consecutive interior. So that could be that could be that, this could be this. So parallel lines means that consecutive interior angles are supplementary. And we could switch that, and we look at these two sides being parallel, and that being a transversal, and we could apply this to all the angles. Okay, excuse me. Why is that over so far? All right. The diagonals bisect each other. Okay. So we want to remember those things, and as we see parallelograms, we can use that information to figure things out. So JH is over here. So JH is right there. So if we think about that, we can see that this side is 8. We can see that it's a parallelogram because of these markings. These two sides are parallel, those two sides are parallel. So one of the properties of parallelograms is that opposite sides are congruent. So put that and we just say, how do we know that? Because opposite sides are congruent. So we knew that that was going to be 8. Okay, what about LH? LH is right here and right there. Well, I think that last one covers that. So that says that the diagonals bisect each other. So that's going to be 6. And that's because the diagonals bisect in a parallelogram. All right, and last one here, KH. Okay, so KH is just all the way across here. We just found out that was 6, so there's not really much to do there. I just realized it's be 2 times 6. And that doesn't really fit into one of the properties except maybe the same one here because it's bisected, so that's how we know we can multiply that by 2, or we could add those two together. All right. Excuse me. Oh. All right. So these are all pretty much highlighted, so it's all good stuff. So what do we have here? We want to find the measure of angle W. So if we look at that, we again see opposite sides are parallel, so we know that opposite angles, so we have a parallelogram. That means that opposite angles are congruent or have equal measures. So I know those two are going to be equal to each other. So 4x minus 9. So you have to be careful. There's two kinds of equations. Sometimes we set stuff equal to each other, and sometimes we add it together to give something else. So if this angle would have been over here, then we would have added these two together and set them equal to 180. So you have to make sure that you know what situation you're in. Now, most of the time, you're going to do a better job if you actually write down your steps. So actually subtracting there, you're going to get x. What happens to people who don't show those steps, sometimes they just add them together and get 7x. It's easy for our brain to play little tricks on us like that when we're not careful. So if we add 9, that's going to be 27. So x equals 27. Now, the question asks us for the measure of this angle. So if I know that x equals 27, I can plug it into one of these. So I'm going to plug it in here. So 27 times 3 is 81, plus 18 is 99. So I know that this angle is 99, both of these. So consecutive angles in a parallelogram are supplementary because of the parallel lines we just talked about. So that's going to be 180 minus 99. So 1 more to 100 and then 80, so that's going to be 81 degrees. Okay. Find the angle measure. So we have C and we want to know A. Well, if we look up here, since they're not right next to each other, that means they're opposite. So A and C are opposite angles across from each other, which means in a parallelogram, that's a symbol for parallelogram, opposite angles in a parallelogram are congruent, so that's going to be 105 degrees. Now, just a side note, we've talked about this in the past. If you're having trouble on a question, especially in geometry, but really a lot of other math classes as well, you can draw a picture. So we can kind of try and draw a picture for this. I don't know how big we need to make that, but okay, and remember the picture, it's just a sketch. It doesn't have to be perfect. It's not like I'm measuring out angles or anything like that. So I'm just trying to get an idea of where stuff is. So C is 105, so I'm going to put it here. So that would be A, B, C, D. So C is 105, and so we just said, well, A should be 105 also. Now D and B are both opposite, and so these are consecutive, parallel lines, transversal. That means they're supplementary. So if we take 180 minus 105 and borrow off of there, we should get 75 degrees. All right. Okay, we got a little proof going on here. The stuff has mostly been filled in for you. So if we know that that's a parallelogram, then that tells us some stuff right off the bat. So ABCD is a parallelogram. That means that AD and BC, opposite sides, are parallel. So we could say AD, line AD, is, probably should have went this way first alphabetically. AB would have been better, except I already have it highlighted in blue there. So I guess I'll stick with it. AD is parallel to BC. And think about, how did we know that? Because that's a parallelogram. So that's the definition of a parallelogram, is opposite sides are parallel. Definition of a parallelogram. Okay, so what do we want to do now? Well, if that's what we're looking at, those two parallel sides, then that would be a transversal, which means we could say something about angle 1 and about angle 2 right now. Angle 1 is congruent to angle 2, and that's going to come from this. So that's going to be parallel lines, means that corresponding angles are congruent. Okay, now we also could say that AB and CD are parallel. Line AB is parallel to line CD. Also by the definition of parallelogram. So you may be wondering, we just said AB and CD lines are parallel, so this can be a transversal. So now I can connect 1 and 4. We could have come this way and connected 2 and 3 and 3 and 4 instead, but 1 comes before 3, so I went for 1 first. So this is redundant. It's extra information that we don't need. So if we focus on the pink lines here, now we can say that angle 1 is congruent to angle 4. And that's because parallel lines mean that alternate interior angles are congruent. And now if we focus on these two and put them together, that gives us our next statement. Okay, so that's the transitive property of angle congruence. So we do repeat some of those proof reasons a lot, so the more you do them, maybe the better that will be for you eventually. Alright, a four-sided concrete slab has consecutive angles that measure this. Is that a parallelogram? Consecutive means one after another, so you're just going around. So 85, 94, 85, 96. So here, these two are not equal, so that means that the angles are not congruent. So the opposite angles aren't congruent. So no, because the properties of parallelograms say that if it's a parallelogram, you have to have opposite angles congruent, and those are not. Okay, so last one here, and we can see that the opposite sides are parallel. That's what that means. Those two are parallel, and that means those are parallel. So it's a parallelogram. These are consecutive angles, so that means consecutive angles are supplementary. So We always, in our class, we start off with an equation, and we want to be careful with that equation. So some students want to simplify right away, which is understandable, but if you make a mistake, you lose the equation point. So we encourage you to kind of not try to simplify on that first step. Just write down the equation. So this situation is a parallelogram, means that consecutive angles are supplementary. So now we'll go ahead and combine some like terms here. So this is all on the same side, so we want to combine things and kind of put it in standard form. So that's when we have the highest exponent first, and then the next. And this is 90. So hopefully, I don't know, I was thinking about doing 2 steps at once, but I guess I won't. So some of you could have done that, I think, probably most of you. Subtract that 100. I was about to do that from both sides. But it's so easy to make silly mistakes that it's probably better to be more careful. So now we have 2x squared minus 57x minus 90. Now, some students try to use the quadratic formula all the time. If these numbers are big, okay, like here and here, big numbers means that it probably factors. Okay, so if you have big numbers in there, that means it probably factors. We don't want you to use the quadratic formula because we don't normally use calculators every day for stuff. So if that factors, then the way we factor, that's going to be 1/2, and then we write 2x and 2x. Okay, if you think about it, if you multiply that out, you get 4x squared, and then you take half that, you get 2x squared, so that's fine. Now, this is negative. That means one of these needs to be positive, and one of them needs to be negative. Then you're supposed to take a times c, so that would be negative 180. And you should be thinking about, because these are opposite, you need to subtract the factors to give 57. Now, I think it should be pretty nice to find that, but if not, then you just start listing all of them. So 1 times 180, 2 times 90, 3 times 60, and hopefully you're like, okay, there it is. That's the ticket. So we want a negative 57. So this is going to be negative 60 and positive 3. All right. So we need to factor out a 2 here to cancel that 1/2 out. So if we factor out a 2, then our final answer is 2x plus 3 and x minus 30. And we could multiply that back together to check, except it says find the value of x, so I wasn't done. That's what happens sometimes. We do a lot of work and we just stop because we're so excited. It said find the value of x. So x could be negative 3/2, or x could be 30. Because if this times this equals 0, then one of them has to be 0. So if x equals 30, then this would be 0. And here, if you don't see how to do that, set it equal to 0. 2x plus 3 equals 0. So subtract 3 and then divide by 2. So those are our numbers. Now we have to think about, do they make sense? So if you plug in 30, that's going to give you a really big number here. And if you plug in 30 here, it's going to give you a negative number. That doesn't make sense. Now if you plug in 3/2 here, that'd be a negative times a negative. That'd be positive, and 3 times that's almost 180, a little bit less than 180, divided by 2 is a little 90, so it's around 90, so that's around 170, so that's okay. And if we square negative 3/2, we get 9/4, which is 9/2, which is 4.5, so this is 14.5. So that works, that's fine. Okay, so it's about that time. Go do your assignment, be good, come to office hours if you need help.